Today, we're pulling back the curtain on one of the internet's greatest unsung heroes. It's this invisible force that makes everything you do online feel instant. And honestly, without it, the web as we know it would just grind to a halt.
You know the feeling, right? You click on a link and one website just snaps into existence, while another one, well, it leaves you staring at that dreaded loading spinner. It's something we all go through, but it's not random. There's a really powerful secret behind that speed difference.
Yup, that's it. Caching. It sounds kind of technical, but the idea is actually super simple, and it has this massive impact on pretty much everything, from your social media feed to the biggest shopping sites on the planet. Okay, let's break this down with a quick analogy. Imagine you need to get some milk. Now, the original source of all milk is a farm, which could be hundreds of miles away. Driving there every single time you wanted milk would be crazy slow, right? Well, that farm, that's your database. But what do we do instead? We go to the grocery store around the corner. That store is your cache, a local, fast, temporary spot that keeps the popular stuff, like milk, ready to go. And this whole grocery store model, it's not just a nice little convenience. It is the fundamental solution to two of the biggest problems on the internet: physical distance and overwhelming demand. So at its core, a cache is just a smaller, much faster layer of storage. We're often talking about super fast memory, or RAM. Its entire job is to keep a copy of the most popular data so you don't have to make that long, slow trip back to the farm, the main database, for every single little thing. So how does this actually play out? Well, when an app needs some data, its first stop is not the database, it's the local store, the cache. And from there, only one of two things can happen. You either get a cache miss or a cache hit. A miss is exactly what it sounds like. The grocery store is out of milk. You have to suck it up and make that long trip to the farm. It's slower, but you get what you need. A hit, though, a hit is when the store has exactly what you want right there on the shelf. The whole thing is over in a flash. And the goal of any good caching system is pretty simple: get as many hits as you possibly can. So let's trace the journey of a cache miss. A user asks for something. The app checks the cache, but nope, it's empty. So the application has to make that long journey to the database. But here's the clever part, right here in step 5. Before sending the data to the user, it puts a copy into the cache. That one little move is what sets up all the magic for next time. And here's the payoff. The very next time someone asks for that exact same data, the journey is so much shorter. The app checks the cache, finds it, and boom, the data is returned instantly. The main database is never even bothered. This is exactly how a viral post can be seen by millions of people without completely melting the servers. But wait, it gets even cooler. It's rarely ever just one cache. The modern internet is actually built on layers and layers of caches, creating this entire supply chain that's designed to get data to you as fast as humanly or electronically possible. And this is where that supply chain idea really clicks. Your own web browser has a cache. Think of that as your pantry at home, stocked with the stuff you use all the time. A CDN is like the big local supermarket, holding all the popular items for everyone in your whole neighborhood. And then you have the application and database caches. Those are like the store's back room and the farm's own warehouse, making things faster right at the source. Each layer does its own part to lighten the load. That CDN layer we just mentioned is a really big deal. A CDN is a global network of servers that caches things like images and videos in data centers that are physically closer to you. So if you're in Germany, instead of grabbing an image from a server in California, you get it from one right there in Frankfurt. It just cuts way down on the travel time for the data. So why do companies pour so much money and engineering time into these systems? Well, it all comes down to 3 massive wins: making their services faster, cheaper, and a whole lot stronger. And the difference in performance is, well, it's just not even a fair fight. Reading data from a traditional database that uses a spinning disk is like going to a huge library to find one specific sentence in a book. Reading from an in-memory cache is like having that book open to the exact page right in front of you. We are talking about responses in under a millisecond. Sub-millisecond. That is so fast your brain literally cannot perceive the delay. It feels completely instant. That's the secret sauce behind all the real-time leaderboards and live updates we just expect now. So when you add it all up, the payoff is huge. It makes things way faster for you. The user. It cuts costs for the company because they don't need as many expensive databases, and it lets them handle those insane traffic spikes, think Black Friday or a new streaming series drop, without everything crashing. A good cache can serve up hundreds of thousands of requests every single second. Okay, but it can't be all sunshine and rainbows, right? Caching isn't a perfect magic solution. It brings its own set of really tricky problems. Because just like a real grocery store, you have to decide what to put on your very limited shelf space. And here's the first big headache. What happens if the milk at the farm gets recalled, but the grocery store has no idea and just keeps selling the old, spoiled batch? Now your cache is serving stale, outdated, and maybe even wrong information. This is a huge problem. The fix for this has a fancy name, cache invalidation. But all it really is a process for telling the cache, hey, that data you're holding is no good anymore, get rid of it. This makes sure that the next time someone asks for it, the app has to go back to the farm to get the fresh stuff. And trust me, getting this right is famously one of the hardest things to do in computer science. And then there's the second major challenge. That super fast memory for caches, it's expensive, so it's limited. You can't just store everything forever. Eventually, your shelves are going to get full. So when a new item comes in, you have to ask, what do I kick out to make room? That decision is handled by something called an eviction policy. There are a few common strategies. LRU, or least recently used, basically throws out that dusty old thing in the back that no one has touched in ages. LFU, least frequently used, gets rid of the item that's been the least popular. And FIFO, first in, first out, just kicks out the oldest thing on the shelf, period. Choosing the right one really depends on how people are using your app. You know, there's a great quote that sums it all up perfectly. It says, caching is all about efficiently reusing data you've already grabbed. That's the whole game. You're making a strategic trade-off. You accept a little more complexity in your system to get these absolutely massive gains in speed, cost, and reliability. So I'll leave you with this question to chew on. Caching isn't just some add-on feature. It is the absolute foundation of the modern web. If every single cache in the world just vanished overnight, what do you think would break first? Online shopping, video streaming, social media? The real answer is all of it. Pretty much everything would break. And that just goes to show you how vital this invisible system really is.